the change of base rule. The change of base rule lets you rewrite any log as two different logs being divided by each other. So the quotient of two logs. And that's a kind of powerful thing. So let's look at it. In general, all it says here is, if you notice, so log base b of a equals log base b of c, which is a new number of a, over log base c of b. So I always think about it as the base goes to the basement and the top number goes on top. So if you have something like log base 207, you're like, I want to rewrite this with the log base 5. So you just go, okay, oops, sorry. That goes on top, base 5, and this goes on the bottom, base 5. And there you go. Use the change of base rule. So let's do an example. You need this rule to evaluate the logs other than 10 or e. So find log base 2 of 9 by changing to base 10. So all we're going to do is go log base, right? I want to rewrite this so 9 goes on top, 2 goes on the bottom. So log base 10 of 9 over log base 10 of 2. Now remember, log base 10 is a common log, so it's write like the log of 9 over log of 2. And if you had like a scientific calculator, this is how you would solve it. You go log 9, close a parenthesis, very important, divided by log 2. And we get that. We want to do the same thing with change of base of e, because we could do natural log. So remember, you could write this as log base e of 9 over log base e of 2. But a nicer way to write it is just natural log of 9 over natural log of 2. And that way, if you had a scientific calculator, you just plug in your calculator again. And you can get the exact same answer. Natural log of 9, close the parenthesis, divided by natural log of 2. Right? Exact same answer. Now, if you have a graphing calculator, most modern ones, if it's updated, you can just put this into your calculator. So we go math. If it's updated, there's a log base toward the bottom, like I have here. And then you just put it in the way you see it. We're going to get the same answer. And there you go. So, but change of base is actually a very important concept in how you can rewrite it using anything. Right? I could also rewrote this as saying base 13. So it would have been log base 13 of 9 over log base 13 of 2. It actually works the opposite way too. If you see this, you go, wait, I can rewrite this as log base 2 of 9. Right? The bottom goes here, top goes there. As long as they have the same base, you can combine them. Last one here. No, this one's very tricky. I can't combine it because they have different bases. You're like, what do I do? Well, the whole thing is about using change of base formula. So what I'm going to do here is, 2 is pretty solid. I can't do anything with 2, but 4, let's change this and change it with the base of 2. So I'm going to rewrite this guy. I'm going to rewrite that. That's probably messy. I'm going to write that with the base of 2 for both. So we're going to rewrite it using base 2 so that it matches. So it's going to be log base 2 of x cubed over log base 2 of 4 plus log base 2 of radical x equals 8. Alright, so I use the change of base on this one to get to have the same base. And I chose base 2 because I wanted to match with this one. Now what does that also let me do? Well, this right here reduces. Log base 2 of 4, right? 2 to a power equals 4. This is just 2. So I have, let's write this as 1/2. I didn't move it, just like, this is log over 2, so I'm just write it as 1/2. So 1/2 log base 2 of x cubed plus log base 2 of radical x equals 8. Now I got to combine this side. So to do that, I got to bring this power to right here. So it's going to be log base 2 of x to the 3/2, or x cubed to the 1/2 is just 3/2, plus log base 2 of x to the 1/2 equals 8. Plus means multiply. So I'm going to get log base 2 of x to the 3/2 times x to the 1/2 equals 8. I'm going to write it like this. Right, because when you're adding, you multiply. Now, these have the same base. I can just add the powers. 3/2 plus 1/2 is just 4/2, or just 2. So 3/2 plus 1/2 is just 4 over 2, which is just 2. So I have this. Log base 2 of x squared equals 8. Right? Now how do I solve this? The way you get rid of a log, you take whatever the base is and you take that to both sides. So this side and this side. That's how you cancel out a log. These cancel out, you get x squared equals 2 to the 8th, which we can figure out, but instead of doing that, I'm just going to take this, I'm going to square root both sides, or take the 1/2 power to both sides. And I get x equals 2. Now 8 to the 1 times, this is 8 up to the 8th to the 1/2 power, so you just multiply the powers and you get 4. Also known as 16. So x equals 16. So there we go. That's the lesson.